Hey everybody, this is Chapter 6, Section 2. Title is Solving Systems Using the Substitution Method. It starts on page 368. Yesterday, or last lesson, we talked about the fact that there's three different ways that you can solve a system. In Section 1, we graphed. In Section 2, we're using substitution. And in Section 3, we'll use another one. So, no graphing in this one. We're done with graphing for a little while. In Section 1, we learned to solve a system of equations by graphing the lines. A system can have one solution if it crossed at a point, no solutions if the lines are parallel and don't cross, and infinitely many solutions if it's really the same line on top of itself. So that's a review of Section 1. In Section 2, we'll learn how to solve a system of equations by using substitution. The system can still have one solution, no solutions, or infinitely many. But you're not going to be able to tell by the graph now. We'll tell you how you know each one of those in a second. Think about the word substitute for a second. A substitute teacher is when one teacher leaves and another teacher takes its place. Okay, so you take something out and put something else in its place at the same time. We're going to do that in math. In the substitution method today, we're going to have one thing take the place of something else. We're going to take one thing out, put something else in its place. Here's the steps to use. To use the substitution method, at least one of your equations must be solved to get the x or the y by itself. So you have to have either the x by itself or the y by itself. Once that happens, take whatever the x or y is equal to and plug that stuff into the other equation. This will make a little more sense after I do a real problem, but at least now you can write down or make sure you see the steps as they're written out. Don't forget, whenever you substitute something in or whenever you plug something in, you should use parentheses. We'll see why here in a moment. After you plug what the x or y is equal to into the other equation, you should only have one variable left in your problem. Okay? Either all your variables turn into x's or all of them turn into y's. You're going to solve for that variable using the steps that we learned back in Chapter 2. Things like distributive property, combining like terms, using inverse operations, all of those things. After you get an answer for one of the variables, so you get like x equals 3, take that number, plug it back into one of your original equations, and solve for the other one. So if I've already solved for x, I know my answer needs to be an ordered pair, so now I'm going to solve for y. And once I get both of them, that's what my final answer is going to be. If your system has one solution, your answer should be an ordered pair. Remember that from Section 1. All right, here's what a problem would really look like. I've got a system of equations, negative 2x plus 5y equals 19, and y equals 3x minus 4. And I'm going to substitute. Remember, the first step was that one of my equations has to be solved for either x or y. Do I have an equation where either x or y is by itself? Sure. This second equation, y equals 3x minus 4, the y is by itself. That's good. That's what I'm looking for in order to do substitution. Now, the equal sign means the same. So y and 3x minus 4 are really the same thing. It's two different ways of writing the same thing. So what I can do is I can take a y out and put 3x minus 4 in its place. I can substitute it in, just like I take a real teacher out, put a substitute teacher in its place. So I'm going to take what y is equal to and plug it into the other equation, where the y is. Here's what I would end up getting. The minus 2x stays the same. The plus 5 stays the same. And I took the y out, and I'm putting 3x minus 4 in its place. That's where y used to be, right? There used to be a y in that spot. Not anymore. I put the 3x minus 4 there instead. Notice, when I substitute it in, I always put it in parentheses. Okay? If I look back at that top line, 2x, negative 2x plus 5, and then the stuff that I had for y, and then equals 19. I don't do anything to that either. Right? So all I did there was I took the 3x minus 4 and substituted it in for y. Took the y out, put the other stuff in. Now it's all stuff that you did back in chapter 2. I have to distribute. So negative 2x stays the same. Positive 5 times positive 3x is positive 15x. Positive 5 times negative 4 is negative 20. And then equals 19 stays the same. I didn't do anything to that yet. Next, I have like terms. Negative 2x and positive 15x are like terms. 2 negatives, 15 positives gives me a positive 13x. Didn't do anything to the 20. Didn't do anything to the 19 yet. In order to get x by itself, I have to get rid of the 13 and the negative 20. I'm going to get rid of the minus 20 first. Add 20 to both sides. Should be getting good at this part by now. Instead of multiplying by 13, I need to divide both sides by 13. And I get x equals 3. That's not my final answer. When I solve a system, I should get usually an ordered pair. That's not a pair of anything, that's just an x. In order to get an ordered pair, I need the y that goes with it. So I'm going to take that x equals 3, and substitute it into one of my two equations. I can substitute into either one I want. One of them is usually easier than the other one, though. So I'm going to take that x equals 3, and I'm going to substitute it into this bottom equation. So instead of an x right here, I'm going to write a 3. Y equals 3, and instead of the x, I'm going to put a 3 in parentheses, minus 4. 3 times 3 is 9. 9 minus 4 is 5. Now I have an x and a y, and I can write my answer as an ordered pair. In this practice problem, this equation has the y by itself. So I'm going to take this stuff right here, substitute it in for the y, and then go on from there. Sometimes you don't have an x by itself or a y by itself. But before you can substitute, you have to get it by itself. So sometimes you have to solve one of the equations for one of the variables before you can substitute. It would be a problem like this. I don't have an x by itself, and I don't have a y by itself anywhere in this problem. But on this top equation, it would be easy for me to get either x or y by itself. It doesn't matter which one I solve for. I can get the x by itself or the y by itself. I just have to pick one of them. I'm going to get the x by itself. So I'm going to subtract y from both sides, and I get x equals 6 minus y. Okay? So I took that top equation, got rid of the y on both sides. Now, x is by itself. X is the same thing as 6 minus y. So what I'm going to do is I'm going to plug into this equation, the one that I haven't touched yet, but instead of an x, I'm going to write 6 minus y in its place. I took the x out. I put the 6 minus y in parentheses. Everything else in that equation stays the same. Now, if I look right there, I only have one variable left. They're all y's. I don't have any x's anymore. Okay, that's good. Distribute. I have like terms. Negative 2y plus 4y. I haven't done anything to the 12. I get a positive 2y. Now, I need to get rid of this 2, and I need to get rid of the 12. I'm going to get rid of the 12 first. Subtract 12 from both sides. Divide by 2, and I get y equals 5. That's not my final answer because I need an ordered pair. I'm going to take that answer, y equals 5, and plug it back into one of the two equations I started with. I'm going to plug it into that one because that one looks easier because I don't have to multiply anything. And I get x plus, but instead of y, I'm going to put a 5 in. Subtract both sides by 5, and I get x equals 1. So my answer is the ordered pair. Remember, x comes first. 1, 5. That one just had one extra step at the beginning where I had to get one of the variables by itself. One for you to try. I would get either this x by itself or this y by itself as my first step. Then I substitute in and go on from there. So we've talked about the special cases. Remember, a system of equations can have one solution like we've already done. You get an ordered pair for an answer. It can have infinitely many, and it can have no solutions. When we were looking at the graph, it was easy to tell. If it was no solution, that means the lines didn't cross. If it was infinitely many, that means the lines were right on top of each other. We don't have lines to look at anymore, so this is what you look for. If all of the variables in your equation cancel out, and you're left with something that is true, that's infinitely many is your answer. If all the variables in the equation cancel out and you get something left at the end that's false, your answer is no solution. Okay, so that's what you're looking for with the special cases now. Here's an example. Solve this system of equation. It tells me to use substitution. Y is already by itself, so I'm going to take what it's equal to and plug it into the other equation. So I get 4x minus 2, and then in parentheses, 2x plus 1 equals 6. So I took the y out, I put the 2x plus 1 in its place. Distribute. Negative 2 times 2 is negative 4. Negative 2 times 1 is negative 2. Okay? Now I have like terms. 4 minus 4 gives me 0x. Those cancel. Those are opposites. A positive 4x and a minus 4x. All my variables cancel. All I have left is negative 2 equals 6. Is negative 2 the same thing as 6? No, it's not. This is false. So my answer would be no solution. All my variables went away. I got something that's false. My answer is no solution. I just stop there. Another example. This y is by itself. So I'm going to take this stuff and plug it in where y was in the other equation. So 2. And then 1/2 x plus 3, and then minus x equals 6. So I took this y out right there, and I put 1/2 x plus 3 in its place. Everything else in that line stayed the same. Distribute. 2 times half. Half of 2 is 1. Whoops, I forgot to distribute. 2 times 1/2 is 1x. 2 times 3 is 6. There's really a 1 right here. So I have a positive 1x and a negative 1x. Those cancel. And what I'm left with is 6 equals 6. Is 6 the same thing as 6? Sure it is, so that's true. So my answer, infinitely many solutions. That's how you get the special case ones in this section. The variables cancel and you get something that's true, infinitely many. The variables cancel and you get something left that's false, no solution. And one for you to try. X is already by itself in this first equation, so I can take this stuff, plug it in where the x was, and then go from there. Okay, spot for you to write your questions, comments, and concerns that you can bring up next time we have class.